polynomial and rational inequalities. This below says use the graph of the function to solve the inequality. So if you look at this problem here, it says solve. And then part A says f of x less than 0. So recall, f of x is the same thing as y. So really we're saying where is y less than 0? So if I think about the y values, this axis is my y-axis, and this is where I measure where my y values are. So where is y less than 0? So if I look at this graph here, I can see that if I pick, let's say, this point right here, that looks like negative 230. And we can see that that y value is positive. So we want where y is negative. So that would happen down here. Like, let's say I pick this point. I could say that looks like my y value. I don't know the x value. But I know the y value is negative 10, which is negative, and that's what we're looking for. So we're trying to find all the x that results in a negative y value. And that's what less than 0 means, negative. So if you think about where that's at, it starts here and it goes to the left. And everything to the left is going to be, the left of negative 4 is going to be negative y values. And then also, if I think about this interval here, between these two, the y values are also negative down here. Okay, so that's really the idea of what we're dealing with here. It's not a complicated idea. We just lose sight of what f of x is sometimes and realize it's just a y value. So what that means for us then, for f of x less than, now this is just less than, not equal to. So I can't include the negative 4, but this is going to be negative infinity to negative 4. And this interval here is going to be from 1 to 3. And that's how we're going to write our intervals for this. And those are the only two intervals where f of x is less than 0. So let's write those out now. So the interval I'm going to write is negative infinity to negative 4 union 1, 3. So there is the actual interval where f of x is less than 0. And that's all we're really doing here. Now let's talk about part B here. Part B says f of x is greater than or equal to 0. So again, I'm looking where all the y values are either equal to 0 or bigger than 0. So that's going to happen on this upper half here. It's going to be up here because those are all my positive y's up there. So anything where my function is above the x-axis is going to be where my f of x is greater than 0, and right on the x-axis is where it equals 0. So if I look at it this way, I'm going to include that value there, and that value is negative 4. And then I'm also going to include this value here on this side, which is 1. So that's going to be my interval for the function where my y value is above 0. And right on these values here is where my function is going to equal 0 because it says greater than or equal to 0. And that's not the only one. We also have this interval here, and it goes all the way out. So now let's write those intervals. So it's going to be from negative 4 to 1. And again, notice I'm using brackets for all of these. And then 3 to infinity. So there's our answer. Because of the equal sign, that's why I'm using the brackets. It's included. Now for part C, it's not really a part, but I want you to understand how these actually work algebraically. Because graphically, yeah, they're very simple once you understand the idea, hopefully. Now what I want to do is I want to talk about these algebraically. So essentially how this works is I find the zeros of this function first. And if I know where f of x equals 0 at, then that helps me to determine where I could possibly be going positive, possibly be going negative, or vice versa. And we're going to create a number line for this. So if I look at my function, it's already in factored form here because I wanted to save a little bit of time here. And I just say, hey, where's this thing equal to 0 at? Let's assume we don't have this picture here. Let's say it's all gone. Okay, so then I'm going to say, hey, it's at x equals negative 4. 1, and 3. So what I'm going to do now is I create this number line. And I put all of those values on it. So -4, 1, and 3. Then I'm going to take a different color here because I want you to be able to see the differences of these two. I'll use a green. Green's cool. Okay, so anyways, so now those are my zeros, if you notice the graph above. So that's where these are at here. So now what I'm going to do is I'm going to pick values around there to see if the y is going to be positive or negative, because this is where it may possibly cross the x-axis at these 3 values. They may not. It could just bounce off of it, but we can figure that out as we pick values. So the first value I'm going to pick is -5. And the way I look at this, here, let me move this out of the way because I'm going to need a little bit of space there. All right, so I think about it this way. If I plug in a -5 here and a -5 there and a -5 there, I don't really care about the number. I just care about the signs. So I can see when I plug it in here that that's going to give me a negative. So I'm just going to write a negative there. And when I plug it in here, that's also going to give me a negative, so I'm going to put a negative there. And when I plug this in here, -4 plus 5, that's also going to be a negative. And I don't really, like I said, I don't care about the number. I just care if it's positive or negative. And if I look at -5, I can say, hey, that value gave me a negative y value. Now I'm going to do the same thing for a number. Now notice I went to the left of -4 because there's nothing else going on after that. So now I'm going to go between -4 and 1. And since 0's between there, I'm picking that one. That's an easy one to work with. So now I'm going to do the same thing. So I put a 0 here, 0 there, and 0 there. And I could see that this first one here, the x plus 4, that's going to be positive. And for the second one, 0 minus 1, that's going to be negative. And then 0 minus 3, that's also going to be negative. Now notice this, a negative times a negative is positive, times a positive is positive. So that's going to be positive here. So I know between -4 and 1, it's going to be positive. Now I'm going to go between 1 and 3, so I'll pick 2. And I do the same thing here. So I'm just going to put 2's here where x is at. Now again, I always have to think about I'm going to be multiplying those signs. That's what I want to think about. So that's how I determine if it's negative or positive. I'm trying to get that out of there. Okay, I got it now. Okay, there it is. So now when I plug that 2 in there, 2 plus 4 is positive. And then 2 minus 1 is positive. And then 2 minus 3 is negative. So a positive times a positive is positive, times a negative is negative. So I know at 2, it's going to be negative. Now I have to try after 3, so let's try 4. Okay, now that's going to be the last one I have to do. And this will actually give me all the answers for both A and B without even seeing the graph of this. And that's what I wanted you to see here. Just by using signs, not really worrying about the numbers themselves, but the signs. So now when I plug in 3 here, and 3 here, and 3 here, 3 plus 4 is going to give me a positive. 3 minus 1 is a positive. And 3, oh no, that should have been 4. I can't do 3. It's going to 0 out here. Okay, so let's go to 4 then. That's what I picked. Don't know why I said that. Okay, so I'm putting 4 in here. Okay, and then we also see why it's a 0 and why it's not going to help us. So anyways, 4 plus 4 is positive. 4 minus 1 is positive still. And then this is also going to be positive. So 4 is going to be positive. So what I see here, and I'm just going to grab a different color so you can see what I see, that when I'm to the left of -4, it's negative. When I'm between -4 and 1, it's positive. And I don't know how high it goes, and I don't really care about that. I'm just looking where I'm less than 0 or greater than or equal to 0. And then when I'm between 1 and 3, it's negative. And then when I'm after 3, it's positive. So you can kind of see how it mirrors the actual graph without really graphing it and getting specific about it. So that's the benefit of kind of doing it this way. I don't have to worry about the graph of it. I can just go through the numbers and realize if it's positive or negative. And if I want the interval where it's greater than 0, greater than or equal to 0, I can pick it, like right here and right here. So I can see it all without graphing it. And that's the beauty of this. That's how we do it algebraically. It's still somewhat an analytical way, but that's the way we do it.